Hi friends, I am Mr. Chezian, former Assistant Commandant with CRPF, and I am also a faculty of Geography. When it comes to UPSC coaching, I teach Geography both for general studies as well as optional subject. So my dear friends, here today in this class, we'll be discussing about some of the very basic facts about Geography. Before getting into these basic facts, let me understand what exactly the subject is all about. What do you mean by geography? The word itself says geography. Graphy means what? Graphy means a study. Dictionary meaning says graphy means a description. Make it very simple. Graphy is a study. Then what is this geo? My dear friends, geo is all about what? Geo means what? Earth. It means I am going to study about Earth. The study of Earth, the description of Earth is what you call them as what? Geography or geography. See, no subject is so simple to be defined, but this gives you an idea what exactly the subject is largely about. And my dear friends, when it comes to geography, the subject is not new to you. Anybody who have studied till class 10 would have always come across this subject called as geography. Because till class 10, say for example, this is one of the compulsory subjects what we have read. And my dear friends, even when it comes to civil service preparation, the UPSC civil service examination, which is regarded as mother of all competitive examination, let me tell you, the kind of question what they ask is not so difficult or not so complex. That doesn't mean that they are very easy, right? Somewhere it lies in between. And my dear friends, whatever we have studied from class 6 to 10, somewhere if I can refresh those facts, somewhere if I can consolidate those facts, if I can add more values to it, that is what the entire preparation for this examination is all about. Now, some of the most basic facts, somewhere today I'll try to bring in. We'll talk about those very simple facts of geography, very basic facts. We'll talk about the shape of the Earth. We'll talk about the basic movement of Earth like rotation and revolution. What exactly is the immediate outcome of rotation? What exactly is the immediate outcome of revolution? Everything we are going to discuss in today's class. And of course, we'll try to add more values. In the sense, whatever the basic facts we know, we'll take it from our past memory. We'll also try to add more informations with the existing memory or the existing facts, what we already know, right? Having said this, right, let me enter into this, say for example, topic. As I said, very basic facts. Let me start with the shape of the Earth. If somebody is asking you, what exactly is the shape of the Earth? One word if you want to somewhere tell them, Earth is more like geoid. What is the shape of the Earth? The shape of the Earth is geoid. But if somebody is coming and asking, what exactly you mean by this word geoid? My dear friends, geoid literally means Earth's shape. It literally means Earth's shape, my dear friends. So if somebody is asking you, what exactly is the shape of the Earth? And somewhere if you're not telling them the word called as geoid, you can tell that Earth looks like Earth itself. Sometimes it's look funny and sarcasm, right? But actually it is not. Because every planet is unique in its shape. No two planet is exactly the photocopy of the same. At least in solar system, I understand you do not have a planet which resembles very close to Earth, right? Maybe for example, if you want to bring the very closest to planet, sometimes you call this planet as Earth's twin. Any idea which planet is called as Earth's twin? If I am hearing it right, my dear friends, Venus. Venus is called as Earth's twin, not even Mars. Venus is called as Earth's twin. Why? The shape and density is more or less similar. It is not same. See, I am of the opinion, even if you go outside the solar system, somewhere the entire universe, if I am just say for example, searching for a planet which is resembling more like Earth, it will not be exactly the shape of the Earth as such. Because I strongly believe that every planet in the entire universe, not only in solar system, will be having its unique shape, right? And somewhere if I just take that unique shape, that's what I call them as what? Geoid. Okay. If I start describing this geoid, how exactly it looks like? See, we say that this Earth is more like a sphere. Not exactly a sphere. It is more like a sphere. Why I say it is more like a sphere, right? Sometimes they say ellipsoid. But I would say it is more like a sphere. But there is a bulge at equator. You do have a bulge here. You do have a bulge at equator. Okay. And one more thing, my dear friends, this poles is also relatively flat. What exactly this word bulge and flat says, make it very simple. When I say bulge and flat, it simply tries to say something that the radius of this earth is not uniform. Place to place, this radius of the earth will change. In that way, if you ask me where exactly I have the maximum radius, entire earth where exactly the maximum radius is somewhere you experience. The maximum radius you experience at somewhere. The maximum radius of earth we experience at equator. And minimum radius you experience at poles. Right? So where I have the maximum radius, equator, and minimum radius, poles. Somewhere even this data shows. For example, when I talk about the equatorial diameter, it is somewhere around 12,756 kilometers. When I talk about the polar diameter, pole to pole, what exactly is the distance? It is somewhere around 12,714 kilometers. It means I have a difference of how many kilometers? 42 kilometers of difference I have in terms of diameter. If I am converting into radius, there is a difference of what? 21 kilometers. It means equatorial diameter is at least 21 kilometer more than that of what? Polar radius. A very important fact. Now comes the question, right? Somewhere I told you a fact. Where exactly I have the maximum radius of this earth? Somewhere around, right? At equator I have the maximum radius. Towards the poles I have the minimum radius. Now comes the very important question. Why? Why there is a difference? My dear friends, see here. Any fast rotating object you take it. Anything. Even say for example, I can take a balloon. I can fill this balloon with water. Somewhere toss it up in the air. And somewhere I'll find that as it reaches a height and it descends, this balloon becomes more spherical in nature. Right? Spherical in nature. But if I start somewhere tossing the same balloon along with the spin, you'll be finding that the same balloon with the water becomes more like a disc-like structure. A bulge will be created. If you ask me why exactly there is a bulge, right? Why exactly equator there is a bulge, right? Try answering yourself, my dear friends, not only here. Any fast rotating object, I'll be having a force which acts outside the center, away from the center, right? This force, somewhere very popular. Even the same principle, the same force is also used to dry the clothes in washing machine. What exactly that force is called as? Well said. That force, we call them as what? Centrifugal force. My dear friends, what exactly is causing the bulge at equator is this force called a centrifugal force. Whenever the earth is rotating at a very fast, say for example, pace, the rocks are thrown away from the center. Say for example, the centrifugal force is the one which is creating a bulge. And remember, my dear friends, in geography, always there is a compensation. If I have a surplus at one place, I should understand that it is always at the deficit experience at some other place. Always there is a compensation. Few places I experience what? Flood. Few places I experience, say for example, a drought. Part of the earth will be experiencing day, another half of the earth will experience what? Night. One hemisphere will experience summer, another hemisphere will experience winter. Always there is a trade-off, always there is a compensation. One surplus is always at the cost of one deficit here. In that way, my dear friends, if I can have a place with an extended radius, it is at the cost of the radius of, say for example, poles. If equator is becoming bulgier, the polar diameter will start shrinking. Tomorrow, if the velocity of the earth increases, the rotational velocity of the earth increases, what will happen? The equatorial bulge will become even more bigger. Poles will become even more flatter. Simple. Okay? Right. Now here, why there is a bulge? Already I said it is because of centrifugal force. In entire earth, if you ask me, where exactly the velocity of rotation at the surface. I'm not saying velocity of rotation alone. Velocity of rotation at the surface. Where exactly I have maximum, if you ask me. The maximum rotational velocity at the surface is felt at equator, 1650 km per hour. As I move away, right, what happens? The velocity of the rotation at the surface decreases. More is the rotational velocity, more will be the effect of centrifugal force. See, whenever I say this statement, when I say the rotational velocity of Earth at the surface decreases towards poles, immediately students will ask me, do you want to say that, say for example, equator, the place at equator will be rotate fast? It means, for example, they perceive as though the length of day at equator and poles itself is different. No, not like that. Length of day is always 24 hours, my dear friends. Of course, slightly we'll be debating on this fact, but later stages, 24 hours. See, I know speed, velocity is equal to distance by time. Here time is constant, right? What exactly is different, my dear friends? Distance, what exactly is covered? Am I right? See the distance, equator, see the distance. A person, assume that a person is standing here. See the distance he is covering in 24 hours. Whereas a person who is standing in the Arctic region, where exactly, Arctic circle, what exactly is the distance he is covering in the same 24 hours? Less. And see a person who is standing here, right at poles, hardly is what? Covering any, say for example, distance as such. Okay, I hope you get it. Time is same, 24 hours. But the distance, what exactly a person covers? Poles, he doesn't move. Slightly away from the poles, but in polar region, outer margin, Arctic circle, yes. He does, say for example, cover a greater distance. But as you move towards the equator, he covers a larger distance. Am I right? So that's the reason I said the highest velocity of rotation right at the surface is experienced where? Right at equator. As you move away, it reduces. So my dear friends, let me sum it up, right? What exactly we said? We were talking about the shape of the earth. What is the shape of the earth? Shape of the earth is geoid. Literally means earth shape. So earth is more like a sphere with a bulge at equator and poles being relatively flat. It also gives me an idea that the maximum radius is experienced at equator and minimum radius is experienced at what? Poles. And why exactly we have this bulge at equator? Why we have that extended radius at equator? It is all because of this force called as centrifugal force. And what is the reason for it? I said the maximum rotational velocity is experienced at equator. Basic facts, right? Now moving on to the next basic facts. Earth movement. What do you mean by this earth movement? See, the combined movement of rotation and revolution of this earth. Put together, you call them as what? Earth movement, right? The combined movement of rotation and revolution. What is rotation? Everybody knows. Spin of earth, you call them as what? Rotation. And movement of this earth around sun, you call them as what? Revolution. Assume that this is sun. If earth is moving around the sun, this movement you call them as what? Revolution. But what is very interesting here, sometimes what adds to complexity, if you ask me, it is all about this rotation and revolution happening hand in hand. See, sometimes I say hand in hand. Hand in hand means what? Simultaneous to each other. When earth is rotating, this earth also goes for what? One revolution. Correct. Now individually I'll see, right? What do you mean by rotation? What do you mean by revolution? Individually if I say it, yes. Spin of earth on its own on its own axis, you call them as what? Rotation. Movement of earth around the sun, you call them as what? Revolution. Okay, right. Now what is the immediate outcome of rotation? Because earth is rotating, what is the immediate outcome if you ask me? Because earth is rotating, the immediate outcome is what? Day and night difference. Why exactly the sun is rising? Why exactly the sun is setting if you ask me? It is all because of what? Rotation. Right? It's all because of rotation. Similarly, if you ask me, what exactly is the immediate outcome of this revolution? Revolution. Because earth is revolving, what is the immediate outcome? Somewhere think about it. Instead of me explicitly or deliberately or immediately, instead of me telling you the answer, just think for a while. What exactly can be the immediate outcome of revolution? Somewhere, right? It is all about what? Season cycles. Why I have summer, why I have winter, why I have spring and autumn if you ask me. The primary reason, revolution. Revolution is not the only reason. I'll add one more reason at the later stage. But primary reason, why exactly it is called as a season cycle? What makes it as a cycle is what? Revolution. Right? So my dear friends, when I talk about rotation and revolution, somewhere When we talk about rotation and revolution, what exactly is the immediate outcome? That also we have taken it, right? The immediate outcome of rotation, I said it is day and earth, day and night. And immediate outcome of revolution is what? Season cycle. Fine, everything is fine. Now what exactly is one complete rotation is called as? If earth completes one rotation, this one rotation is very popularly called as 1 day. Normally we say, right? Normally we say for examination, preliminary examination, I have 40 days, 45 days. What exactly is 1 day? 1 day is nothing but what? Time taken by earth to complete one rotation. Then comes another question. What exactly is one complete revolution is very popularly called as? Very good, right? It is 1 year. 1 year. See, when I say very good, somewhere I assume that you would have said the answer. Okay, right. So one complete rotation I call them as 1 day. One complete revolution I call them as what? 1 year. Okay. So what is rotation? What is revolution? We have an idea. The combined movement of rotation and revolution is what? We call them as what? Earth's movement, or simply you call them as what? Earth movement. Now what we'll do, as I said, I'll try to add some values to it. Okay, values to it. Say for example, we know some of the facts. With that facts, known facts, I'll try to add more values to it. Right. First, I'll start with this earth rotation. All this thing what we have said, right? What do you mean by earth's rotation? Spin of earth on its axis, right? Somewhere either you can call it as what? Spin of earth on its own axis, or I can say, more technical terms I can say, angular movement of earth on its own axis, you call them as what? Rotation. Over. That's what we said. Already we discussed about. Earth takes 1 day to make one complete revolution. Otherwise we said, right? We said that. Somewhere we raised a question. What is the time taken by earth to complete one rotation? 1 day we said. And already we said, rotation of the earth is causing what? Day and night difference. Everything we know. And one more fact, already we know this fact, but still if I am just adding it, in what direction that earth rotates, if you ask me. Earth rotates from what? My dear friends, very important, west to east. See, normally people say, they'll ask a question, which direction earth rotates? Clockwise direction, counterclockwise direction. This question itself is wrong. Because when I say clockwise and counterclockwise direction, I should also mention or specify that which poles above, placing myself above which pole this question has to be asked. If I am somewhere seeing this earth rotating, me somewhere placed above this north pole, it looks like counterclockwise in direction. If I am placing myself above this south pole, then it looks what? Clockwise in direction. If I do not specify which pole, what is universal? Is this direction called as west to east? My dear friends, just because earth rotates from west to east, it appears all celestial bodies, they move from what? East to west. Simple. Is the sun rising and setting, if you ask me? No. Is the sun moving? No. We are talking about what? Heliocentric concept. Correct? Entire solar system, the planets are revolving around what? The sun as such. If that is the case, what I understand, my dear friends, sun do not rises, sun do not move. It is the earth which is rotating. It appears as though the sun is moving. Not only sun. When talk about, say, for example, stars. Which direction stars rise, if you ask me? Star also rises in the east and moves towards the west. Sun also rises in the east and moves towards the west. What about moon? Moon also rises in the east and moves towards what? West. And all this celestial object starts from the east and moves towards the west for the simple reason. Earth moves from what? Or rotates from west to east. See, for example, assume that that's okay. I'm just taking a journey. I'm going somewhere. Assume that I'm just going somewhere, taking the very favorite seat called as window seat. I'm having a journey, say for example, I'm just going by a bus or a train, occupying this window seat. I do not know how many of you would have noticed it, but I strongly believe that everybody, say for example, somewhere we would have noticed this. For example, it will appear as though every mountain will be moving somewhere towards your back. And somewhere I understand trees will also be moving somewhere, say for example, in a backward direction. Now ask yourself a question. Is this tree and mountains, are they moving? No. We are moving in a forward direction. So it appears as though all this, say for example, mountains, trees, etc., they move in what? Backward direction. Correct? The same logic is applicable. Just for the simple fact, earth moves from west to east. it appears as though every celestial object moves from what? East to west. So far, what we have seen is very basic concept. Very basic concept. Anybody can answer it, right? Because all that what I have taken now, they are actually there in what? Say, for example, they are there in class 6th NCERT. But here I'll ask you a question. Fact, slightly I'll go for a value addition. Somewhere, my dear friend. See, if I ask you, how much time does Earth take to complete 360 degree of rotation on its own axis? Right? Somewhere if I just talk about it, right? How much time does Earth take to complete 360 degree of rotation on its own axis? Normally people say, what is this? Very basic fact. It should be 24 hours. But my dear friends, let me tell you, if this is the question, and let me tell you, my dear friends, answer is not 24 hours. This is what I call it as what? Value addition. Time taken by Earth to complete 360 degree of rotation on its own axis is 23 hours, 56 minutes and 4.09 seconds. This is the time taken by Earth to complete 360 degree rotation on its own axis. Then immediately we ask a question. What is this? Altogether you are bringing a new fact. Then what is this popular 24 hours is known for? I'm not denying 24 hours is also what? 24 hours is also a day. I'm not denying the fact. But the only fact what I want to tell you, 24 hours is not 360 degree of rotation. 24 hours is actually 361 degree of rotation on its axis. There is a difference. It means, my dear friends, we have two types of day. The time taken by Earth to complete 360 degree of rotation on its own axis, what I have taken as 23 hours, 56 minutes and 4.09 seconds. See, this examination, any competitive examination for that case, being exactly precise is not needed. See, what is the ultimate objective? Knowledge is one side, I'm not denying the fact. Approximately in 1 minute, I have to read the question, understand the question, 4 options will be given, right? I have to eliminate 3 and I have to select one best option. So there, competitive examination, I strongly believe that, say for example, precision is not needed. Approximation is the key for the success. In that way, first and foremost, though I say it is 4.09 seconds, I don't want to carry this 4.09 second further. Approximately, I'll take it as 23 hours and 56 minutes. That is more than sufficient, right? This approximation and all, you leave it, right? Sorry, excuse me. Precision and all, you leave it. We'll go for approximate value. 23 hours and 56 minutes. My dear friends, the time taken for Earth to complete 360 degree of rotation, which takes nearly 23 hours and 56 minutes. This day, very popularly, we call them as what? Sidereal day. We call them as what? Sidereal day. And the time taken by Earth to complete 361 degree of rotation on its own axis approximately, and which precisely takes 24 hours, my dear friends. This day, very popularly, we call them as what? Synodic day. Right? Sometimes we also call them as what? Solar day. Either you call them as synodic day or you call them as what? Solar day. It means I have two types of day. See, what is very popular, I do understand. Say, for example, even if you want to give an ultimatum to anybody, you say, I'll give you 24 hours. I'll give you 48 hours. I'll give you 72 hours. Never will say, right? I'll give you 23 hours and 56 minutes. People will laugh at you, right? So this is the most, say, for example, popular fact. Only thing is that I should know what exactly it means. That's what I have to understand. Okay. Now, my dear friends, see here, somewhere, if I have to understand what exactly is this, right? Right. If I have to understand what exactly is this 24 hours, right? I'll try to understand what exactly is 24 hours. See here, popular day. When I say 24 hours is a popular day. I'm not denying the fact. Now, only thing is that let me try to understand what exactly is this 24 hours. Okay, I'll put it this way, right? I'm just giving you some of the options. Space constraint, I'm just writing in some corner. I'm just giving you 4 options. You think for a while. Of course, right? I'm going to answer on your behalf, but somewhere at least we'll understand what exactly is this 24 hours. Whenever I say one day, one complete day, 24 hours, I'll give you 4 options. Somewhere you think that what is the best option available. Number 1, right? Sunrise of today to sunrise of tomorrow, right? Sunrise of today to sunrise of tomorrow. Option number 1. Option B, sunset of today to sunset of tomorrow. Option number B. Option number C, noon of today to noon of tomorrow. Option number C. D, all of the above. All of the above. Somewhere think for a while. I have given you a question. I have asked you, right, among the 4 options given, according to you, what is the best option available? Sunrise. Today sun is rising. Tomorrow also sun will rise. Can it be 24 hours? Or sun is going to set today. Again tomorrow the sun will set again. Right. Will this period be 24 hours? Or noon to noon? Or all of the above? Think for a while. And my dear friends, see here, you will be having only 2 choices here. What are the 2 possible choices? What you will be available means what you will be having. Doubt what you will be having, I'll tell you. You will be having a doubt between noon to noon or all of the above. Some of you will go for all of the above. What is this? Sun is rising today. Tomorrow also sun is going to rise. Approximately it is 24 hours. Yes, I do agree. Approximately it is 24 hours, but not precisely. My dear friends, only one place on this earth, every day sun rises at the same place and sun will be setting at the same time. Sun will be rising at the same time and it will be setting at the same time. That is equator. Equator is an exception. If you are away from equator, right? Equator means not in equatorial region. I am talking about equator as a line. Anywhere outside this equator, every day the sunrise time and sunset time will be changing. Simple. When I talk about summer, what do you mean by summer? Longer day, I call them as summer. If the days are longer, it means sun has to come early. Winter is known for what? Shorter days. Whereas it is compensated by longer nights. So to understand summer and winter in simple fashion, assume that on any ordinary day, if sun rises at 6 a.m., if the sun comes before 6 a.m., it is summer. The sun comes after 6 a.m., it is winter. Simple way of understanding. Again, what I am saying is according to the local time. Okay. If sun comes early, if sun is coming early, it will be leaving late. Okay. If sun is coming late, it will be going early. Alright. Summer, the sun is more like, say for example, a very dedicated civil servant who will be coming to the office very early, but going back to home very late. He'll be completing all the work and he'll be going, something like that. Alright. Winters, sun is more like non-serious, say for example, civil servants. They'll come to office very late and quickly they'll be going, something like that. Okay. Bad example, but still, somewhere I'm trying to tell you what exactly is summer and winter. But my dear friends, one thing I understand, every day the sunrise time and sunset time is going to change. What will not change is noon. My dear friends, whenever I say noon, exactly during noon, my dear friends, my watch will be showing what time if you ask me? My watch will be showing what? 12 p.m. By convention, you call them as what? 12 p.m. Neither, say for example, when I talk about AM and PM, there is slight confusion, but by convention, noon means we call them as what? 12 p.m. So 12 p.m. of today to 12 p.m. of tomorrow, exactly how much time we have if you ask me? 24 hours. That's the reason I said noon to noon. Okay. So when I talk about noon to noon, it is exactly 24 hours. Now I should understand what is noon. Okay. Once I understand, my dear friends, what is noon, right, I'll have more clarity. Right. Only thing is that I'm trying to bring the difference between sidereal day and synodic day. See here. Noon. My school days, they taught me noon means sun will be above my head. Not necessarily everywhere, every time. Okay. But as of now, just for understanding, I'll take it. Right? Sun is placed exactly above my head. Okay, fine. I call them as noon. Head sun position. But later, in our class itself, we'll clarify that. Sun placed above your head. Technically, we call them as what? Vertical sun's rays. Vertical sun's rays can happen only between Tropic of Cancer and Capricorn, that too on a specific day of a year. Not every day. Specific day of a year. Only then I'll be having sun's vertical rays. Just for understanding purpose, I am taking it. See, my dear friends, a person is experiencing sun's vertical rays exactly above his head. So let me call it as what? Noon. Right? This particular place is experiencing noon. Day 1, right? Noon. Day 1, noon. Okay. Right. Then what happens? One day. One day means what? Earth is going to rotate. But I know the fact. Whenever Earth is rotating, I understand Earth is not only rotating. Along with its rotation, Earth is also revolving. It is also moving in its orbital plane. So what happens, my dear friends? Along with this Earth's rotation, this Earth is also going for what? A kind of a revolutionary movement. It is going for a movement. It is going to get displaced in its revolutionary orbit. Right? So after 360 degree of rotation, Earth has rotated 360 degree of rotation. Right? It is over. But very carefully, if I look at it, exactly above his head, there is no sun. If sun is not there, my dear friends, it is not noon. 360 degree of rotation is over, but he is not experiencing noon. So this particular place, in order to experience noon, how many degree they have to tilt further, we have to understand, we have to somewhere identify it. In that way, I'll go for a very simple calculation. See, this calculation is not needed. Only thing is that outcome I should take it. For example, assume, right? I'm talking about the revolutionary orbit. In revolutionary orbit, my dear friends, assume, say, for example, 365 days approximately. Again, this fact is not correct. Later, I'll modify it. Later, I'll correct it. 365 days. In 365 days, what exactly is that angle, what it is going to revolve in its orbital plane? 360 degree? 365 days, 360 degree. It means one day, approximately how many degree Earth will move in its orbital plane? Approximately. Don't tell me it is 0.97, etc. Round it off. It is approximately 1 degree. Correct? It means every day, Earth is going to move 1 degree in its orbital plane. That is what it is written here. See? Very carefully if I look at it. Earth has completed, see, 360 degree of rotation is over. Something like that, right? Earth's rotation is over, right? After having its rotation, after completing 360 degree, you're not experiencing noon. In order to experience noon, this Earth has to tilt how many degree? Approximately 1 degree. Once Earth rotates 1 degree, now this is the time or this is the position, what I call them as what? Noon, right? I'll rub all this, say for example, these figures and facts. Right? I'll rub this. All this I have just taken it, right? See for example, again, very carefully look at it. You're experiencing noon. 360 degree of rotation is over. No more noon, right? You tilt further 1 degree. Again, what exactly you experience is a vertical sun's rays. If this person is somewhere placed here, am I right? Somewhere he is placed here. He'll be somewhere the sun will be positioned exactly above his head. Okay? Now I understand what exactly is sidereal day and synodic day. This 360 degree of rotation, you call them as what? You call them as what? Sidereal day. And plus 1 degree of adjustment put together, you call them as what? Solar day. Right? Very important. Right. Now, if I can understand the difference between sidereal day and synodic day, one more time, my dear friends, somewhere if I just talk about it, see here. Somewhere I want to bring in what exactly is a sidereal day. The sidereal day, my dear friends, in simple words we say, if Earth is completing 1 rotation with respect to a distant star, means infinity. or a star which is located far away from the Earth, I can take it. That is what I call them as what? Sidereal day. If Earth is completing one rotation with respect to Sun, noon to noon, am I right? You call them as what? Synodic day. Why synodic day is also called a solar day? Because the reference point of rotation is what? Sun. Okay. So what exactly is sidereal day and what is synodic day? We have an idea. I repeat again. One complete rotation of Earth with respect to a distant star, you call them as sidereal day. One complete rotation of Earth with respect to Sun, you call them as what? Synodic day or solar day. Somewhere for completing one rotation with respect to Sun, as I already told you, Earth approximately take 361 degree. Sidereal, Earth exactly takes 360 degree of rotation. And of course, this 361 degree approximate rotation, how many hours it takes? Precisely 24 hours, precisely. And 360 degree of rotation approximately takes 23 hours and 56 minutes, right? Now, whenever I say day, what is day? Day means one complete rotation. When I say one complete rotation, always comes a question, with respect to what? If it is with respect to Sun, it is solar day. If it is with respect to a distant star, it is sidereal day. Simple. See, on an everyday basis, if I start watching, best place of reference in Earth, if you ask me, for celestial observation, assuming that it is free from clouds, equatorial region. Because I said, right, equatorial region is the one place where exactly the sunrise and sunset takes place every day, same time. If I am there in equatorial region, I am somewhere, if I am looking for the star rays, every day star will come 4 minutes early. Every day. Because that is, say for example, that is what when I talk about sidereal day is all about. 4 minutes less than the solar day. Assuming, say for example, today one star is coming at 8 p.m., rising at 8 p.m. Tomorrow this star will be rising at 7:56 p.m. Day after tomorrow the same star will be rising at what? 7:52 p.m. So every day the stars will come 4 minutes early, right? So sidereal day is more like the reference with respect to a distant star. My dear friends, there are two types of days. We do have a lunar day, third type of day, right? But here onwards, once I know that, okay, there are two types of days, here onwards when we talk about our further discussion, we will not take into consideration of sidereal day. We will be taking into consideration only of synodic day, number one. Number two, there, I will not take 361 degree. I will not take 361 degree. I will consider only 360 degree. Why I am telling you? Because this 361 is that angle what exactly Earth would have rotated on its own axis. But the same 361 degree with respect to, right, on its own axis is also 360 degree with respect to what? Sun. You getting it? So somewhere when I talk about synodic day, I am going to take this synodic day, but not 361. Only 360 I am going to somewhere consider. Only 360 I am going to consider. For the simple clarification I said, right, this 360 is not on its own axis. It is with respect to what? Sun. This is what the value addition, what I said. Basic facts, all the basic facts what we have seen is there in class 6th NCERT. But the difference between sidereal day and synodic day is what? The value addition, what we have. My dear friends, we will be having more of sessions of similar topics, simple facts or the simple concepts along with the value additions. As the time progress, as the day progress, we will also come up with what? The new videos. So thank you and I wish you all the best for your competitive examination preparation. God bless.